So in this video, we will discuss about the speed of the electron revolving around a nucleus in a particular orbit. For that, let me consider an atom. Let this be an orbit of an atom, and we know the center of this will be a nucleus. And if the atomic number of this atom is equal to some Z, we know the charge of the atom will be charge of the atom or charge of the nucleus will be, we know if the atomic number is Z, we have Z number of protons, and we know the charge of a proton is actually E, that is actually 1.6 into 10 raised to minus 19 coulomb. This is actually positive 1.6 into 10 raised to minus 19. So the charge of nucleus will be number of protons, that is actually Z, into charge of a proton. And we know the charge of the electron and charge of the protons are the same, but they have opposite sign, in which proton is positive. So the charge in here will be Ze. And we have an electron E revolving around the nucleus in a circular orbit. And let the distance of this electron from the nucleus be the radius or r. Okay. Now we have the electrostatic force of attraction between this electron and the nucleus. That is, electrostatic force will be, we can apply the Coulomb's law. That is actually 1 by 4 pi epsilon 0. Q1 is actually Ze. Ze times the Q2 is E upon R square. This epsilon 0 is the absolute permittivity of the free space. So on simplifying this, see, this is actually the Coulomb's law is 1 by 4 pi epsilon 0 Q1 Q2 by square of the distance between the charges. Here this one is Q1 and this is actually Q2. Also, on simplifying this, you will get 1 by 4 pi epsilon 0 Ze square divided by R square. See, this is only the magnitude of the force. If we represent Fe as the electrostatic force, we are only interested in finding the magnitude. Okay. I'm not considering the charge of the electron because the charge of the electron is actually negative. But right now we only need the magnitude. So call this as equation number 1. And we know for any rotation, there is a type of force which is always needed, and that is the centripetal force. And we know the centripetal force is equal to, we know the centripetal force is equal to mass of the electron, whatever be the body rotating, we have to consider its mass. So m v square, the linear velocity of this electron, divided by r. So this is the centripetal force. And this centripetal force is provided by this electrostatic force because there is always an attraction of these two charges. So here the centripetal force is provided by electrostatic force. If the electrostatic force and centripetal force are unequal, then this electron cannot stay in this orbit. Either it will spiral inside or it will move outside. Okay. So for equilibrium, these two forces must be equal. Let me represent the centripetal force as some Fc. So we have Fc, centripetal force, must be equal to electrostatic force. And I can equate these two. On the left hand side, we have mv square divided by r is equal to 1 by 4 pi epsilon 0 Ze square divided by r square. For convenience, let's take this 1 by 4 pi epsilon 0 as k. That is actually the electrostatic force constant. So let me replace this one with k. So what I'll get is mv square divided by r equal to kze square divided by r square. I can cancel an r here and one of the r's in here. So the expression become let me erase this. So the expression become mv square is equal to kz square divided by r, since one of the r's will get cancelled. So if I take r to here, I'll get r equal to, and take this mv square to the bottom, I'll get k equal to z square divided by mv square. Let me call this as equation number 3. And I have to consider the Bohr's quantization principle here. So according to Bohr's quantization principle, Bohr's quantization principle, we know the angular momentum L must be an integral multiple of h by 2 pi. Okay, that is angular momentum must be an integral multiple, that is this n should be an integer or natural number. The n should be a natural number, sorry, not an integer, times h by 2 pi. This is called Bohr's quantization principle. And we know the angular momentum L is equal to, for rotation, angular momentum will be mvr. V is the velocity, r is the radius. Let me take this as equation number 4. On substituting this one in this equation, we have mvr equal to nh by 2 pi. That will give r is equal to nh divided by 2 pi mv. I took this mv to the right. So this is equation number 4. And we know both this equation tell about the radius. So they must be equal. That is, equation 3 equal to equation 4 means equation 3 equal to equation 4 means we have kz square divided by mv square, that is this one, must be equal to this one. So nh by 2 pi mv. Here also you can cancel a v here and one of the v's from here. So cross multiplying, you will get kz square into 2 pi m, that is taking this to the right, equal to nh into mv. We only need v, therefore v is equal to, can cancel this m. So v is equal to 2 pi kz square divided by nh. Okay, so this is the expression for the velocity of an electron orbiting around a nucleus. Okay, so this is the speed of electron. Also, let me write this expression again. We have v is equal to, velocity of electron v is equal to 2 pi kz square divided by nh. Now what I'm doing here is I'm multiplying the numerator and denominator with the constant c. C is the speed of light. Okay, its value is actually 3 times 10 raised to 8 meter per second. So I can write this as 2 pi kz square by, let me take this ch as ch together. So ch divide into c by n. Clear? See, this equation doesn't change because I'm multiplying both the numerator and denominator with c. And now for hydrogen atom, that is for hydrogen, we have its atomic number is 1. And this side is actually a constant, and if I plug in the values of the constants in here, I'll get V equal to, that is 2 into this pi is actually 3.14 into, see, this value is, this is electrostatic force constant. Its value is 9 times 10 raised to 9 into this E is actually the charge of electron, so 1.6 into 10 raised to minus 19 square divided by, so see, for Z we have 1, so there is a 1 in here, that is K is 9 into 10 raised to 9 into 1 into 1.6 into 10 raised to minus 19 square. C is the speed of light, 3 into 10 raised to 8 into H is Planck's constant, 6.636 into 10 raised to minus 34 times C by N. Now if I simplify this, that is the variables on the constants on the left of C by N, I'll get this value. On simplifying, I'll get V is equal to 1 by 137. So the final expression will be, for hydrogen atom, we have 1 by 37 C by N. And we call this 1 by 137 as fine structure. This is the fine structure constant. Fine structure constant. Clear? So if we consider the first orbit, we have V on the first velocity of electron on the first orbit, we have C by 137. C by 137. That is, the velocity of electron in the first orbit is 1 by 137th of the speed of light. It's a very high speed. Clear?